Okay. Hello, everyone. Good morning. I am Suchika, and I work for the ColdFusion team as Senior Lead Software Engineer. I've been part of the ColdFusion family for about 10 years now. And so I've worked on a lot of features like language scheduler. And I think some of you must have seen me presenting on language or scheduler in one of the earlier summits. Right. Uh, I'm also responsible for releasing the Docker images for ColdFusion. Uh, let's talk about today's presentation. So I'll be talking about containerizing your ColdFusion installation. Right. So what is the first word that comes to your mind when you hear containers? Right. So I'm sure all of you must be thinking about Docker. Right. So we'll be talking about Docker and containers in the entire presentation. Let's look at the agenda. So the agenda is we'll start with what is Docker. So basic definition on what is Docker and what are containers. Then differences between virtual machines versus containers. Then an overview on Docker architecture. We'll take a look at a typical Docker workflow. Then we'll finally understand the ColdFusion Docker images that we ship for all of you guys, and finally extend that Docker images to build some simple applications. Right, so let's start. Now, what is Docker? Right, so Docker is basically a platform for building, running, and shipping applications consistently. So the term that I'm emphasizing here is consistently. It basically means that you can run your application on any environment, on your dev environment, on your production environment, on my machine, or on your client's machine, everywhere, and it doesn't fail. Right, so in all our years of software development, all of us have faced this, right? It works on my machine, but when you give it to your customer or your client, he says it is not working, right? So why is that? So why do we face such issues? Some of the reasons would be maybe one or more files are missing. Like, so when I was building an application, I included few files, but when I gave it to you, some or one or more files would be missing, right? Other reasons would be software version mismatch. So I was running the application on basic maybe ColdFusion 2023 with JDK 17, but when you were running the same application, maybe you were running on ColdFusion 2021 with JDK 11, right? So there's a version mismatch. They could also be different configuration settings. So maybe I've added few JVM flags in my environment, which was not added in your environment, or maybe a few mappings or environment variables were defined for applications which were missing in your environment, right? So to avoid all of this, Docker was born. So basically, Docker can help you to run your application in all the environment without failing, without facing that it's running on my development environment but not running on production environment. So you will not face all of these issues if you're using Docker. So let's see how Docker helps us in that. So what Docker does, it basically packages your application and all the dependencies that your application needs, and into one image, and that you can run anywhere, right? So this helps you in setting up your application in any environment, maybe development stage or production environment. It becomes very simple. So suppose a new person is joining your team, right? So earlier, if your application was not on a Docker environment, they would have to install few softwares, configure few settings, and then basically run your application, right? So it might take an entire day or more than that to set up your application. But with Docker, it becomes very easy. They simply have to pull your image and then run a container out of that image, right? So what Docker does is it runs your application in an isolated environment, which is called a container, right? So when you are running in an isolated environment, it also helps you to run different versions of your applications in at a simultaneously in the same machine, right? So you can have your application running on ColdFusion 2023 in one Docker container, and in the another Docker container you could have your application running on ColdFusion 2021 as well, right? So you can have different versions of your applications running on the same machines, but since they're running on isolated environment, they won't interfere with each other, right? So there's one more benefit, that bringing down an application and cleanup is also very easy. Earlier, you would have to uninstall your applications, delete your mappings, delete your environment variables, and so on if you have to bring down your application, right? But with Docker, it becomes very easy. You just have to remove the container and your application goes away, right? So these are some of the benefits with Docker. Uh, Whenever we are talking about Docker and containers, we tend to have a comparison with virtual machines, right? So we'll first see what virtual machines are. So virtual machine is basically an abstraction of a physical machine or a physical hardware. Let's see a typical architecture of a virtual machine. So you have a host hardware and a host OS, which can be anything, a Windows machine or a Linux machine, anything. And then on top of it, you have, as you can see in the picture, that you have three isolated environments. These isolated environments are what is a virtual machine, and each of these virtual machines can run a application of its own, and it also has a guest OS packed with it, right? So that OS can be anything. It can be Windows, Linux, or Mac. And how do you create and manage these virtual machines? You can create or manage these virtual machines using an hypervisor, right? Some of the hypervisors that are available are VMware, VirtualBox. These are cross platform, so you can run on Windows or on Linux as well. There's one more, which is Hyper-V, which is available only for Windows, right? So even in virtual machines, you see that applications are running in a isolated environment similar to containers. Then what's the drawback, right? So these are few drawbacks. Now each of the virtual machines or a VM needs a full blown operating system of its own, right? So it takes up a lot of memory and space on your host hardware, hence it is resource intensive. It is very slow to start. So because the whole operating system has to be loaded every time a VM starts, hence it is slow to start. Also, you have a operating, every VM has its own operating system, so you have to maintain that operating system. You have to get it licensed, or patch it. If there's a new security vulnerability in that OS, you have to patch that OS. So maintenance and also licensing has to be taken care of for each of the VM, right? So that becomes difficult. And all of these containers give us a lot of benefits, right? So containers are also isolated environment where you could run your applications. Uh, what are the advantages? It definitely helps you to run multiple applications in isolation. So you can run multiple versions of your applications in a single system, or on different applications as well on a single system. They are lightweight because they don't have a full blown OS packed along with it. So they are very lightweight. They use the OS of the host. They don't have a OS of its own, so they're lightweight as well. They start up very quickly, and also they're not resource intensive. They are not going to use up a lot of your memory, CPU, and a lot of other hardware resource of your physical machine, right? So these are the advantages of containers. We'll see how a typical container works. So it's similar to the virtual machine. So instead of you have a host hardware and a host OS, which could be anything, a Windows machine or a Linux machine, and then you have multiple applications running in an isolated environment, right? So these isolated environments are containers, and as you can see, each of these applications do not have OS of its own. They're using the OS of the host, which may be Linux or a Windows. And how do you manage these containers? You create and manage these containers using the Docker engine, right? So the Docker engine basically will help you to create containers. So on a Linux container, you could run Linux applications, but on a Windows container, you can run both Windows and Linux containers, because on Windows there is a subsystem for a kernel which can run on top of your Windows machine, that helps you to run Linux containers as well on a Windows machine, right? And how do you run it? on Mac. So on Mac, you can only run Linux containers. So Mac also, we have a kernel that ships along with the Docker engine, and then that helps you to create Linux containers on Mac, right? Okay. So now that we've seen virtual machines and Docker containers, let's have a look at Docker architecture. Uh, just checking if there's any questions in between. Okay, sure. Okay, so let's look at the Docker architecture. So what you can do is Docker basically follows a client server architecture, and the client and server talk to each other using REST API. So it has three components: a client, a Docker host, and a Docker registry. Okay, so Docker host is basically the environment where you will build, execute, and run your applications. It has the Docker daemon or the Docker engine, and all the Docker images and containers are built out of this in this Docker host, right? So then you have a Docker client where you could run these commands: Docker pull, build, and Docker run, using which you could basically pull images from the registry and build images once you have pulled those images, and also run containers out of those images. So in the client section, you can run these commands: pull, build, and run. Docker host is the environment where basically all your images and images are stored and containers run. And registries, where registries like Docker Hub or your AWS ECR and all of that, where all of these images are basically stored. Right, so images like ColdFusion or Elasticsearch or anything, all of those are stored on Docker registries like Docker Hub or AWS ECR, from where you can pull the images. Right, so what you do is you pull the images from the registry, and then that gets stored in your Docker host, and then you can also build images, and then that image can also be pushed to Docker registry. And also whatever images you have pulled from Docker registry, that can run into containers using this Docker run command. So this is a basic architecture of Docker. We'll see how what a typical Docker workflow looks like. So we start with a Docker file where basically you define your application, your base image, and then what your dependencies of your applications. You install your applications on all, and all of those instructions are put inside this Docker file. Once you've built your Docker file, you build it into an image using the Docker build command, and then you have an image. Once your image is built, you can test that image using Docker run, and then you have a container, and you can run your applications and all your tests inside that container to see that your application is running properly. Once you've confirmed that your image is proper, you can push that image into a Docker registry, or which could be a Docker Hub or AWS ECR, or you could have a registry which is private to your company, store on Artifactory or anywhere else, right? So you push that Docker image, and then anyone from your company, or if it's publicly available, people can pull that Docker image from the registry, and then similar from that image they can build container, right? So this is a typical Docker workflow. It starts with a Docker file, and then you build image out of it, and then you push that image to a registry, right? So that's a typical Docker workflow. Now that we've understood Docker and containers and what's the difference between containers and virtual machines, we'll have a look at the ColdFusion Docker image that we built for you. Before that, it's important to touch on the package manager, because whatever now everyone's moving to a microservice architecture. So even ColdFusion had a monolithic structure, and we had a huge installation size of about maybe 1.5 GB. Now we've reduced it to bare minimum that has a core packaged in it. So size of the core ColdFusion service, which includes the JRE, is only 146 MB, right? So if you have a zip installation with only the bare minimum core services installed with it, it's only 146 MB. Now, if you want any packages to be installed in it, or if you want to remove or update any packages, you can do that using ColdFusion Package Manager, and or which is a CFPM CLI, or you could also use our ColdFusion admin to install or remove or update the packages, right? This, and if you're unsure of what packages have to be installed for your application, so suppose you have an application that you built earlier and then now you want to dockerize it, you're not sure on top of the core what app packages have to be installed for that application, you can basically run a code scanner on your application. So it runs through your code base and would suggest what packages have to be installed. This code scanner can be run through the CFPM CLI itself. So you can say scan and then path to your code base, and basically this URL, which includes the host name of your server and then port. If you say scan and install, it will uh, also install the packages that is required for your application, right? So this is about package manager and how it helps you to build a very small Docker images with whatever packages that is required for your application. So now you don't have to have a 1.5 GB installation of your ColdFusion. You can simply have a core ColdFusion service along with few other packages that is required. So maybe if you're running an application that uses PDF services, you just need PDF or and HTML to PDF to be installed along with your application, right? Now let's look at the ColdFusion Docker image, right? So what is the ColdFusion Docker image that we build for you? So what we do is we have a Docker. How do we build it? We have a Docker file with it. We have installer properties file, which is basically to set up few settings with your installation. Then along with it, we also ship a startup script, which runs once your container is up. So it's the first script that runs. And then we distribute that image to Docker Hub and AWS ECR. So basically you can pull all our images from Docker Hub and AWS ECR. Then let's look at what this Docker file that we built contains for in the Docker image that we build for you, right? So the Docker file basically has a base image, which is the latest Ubuntu image. So currently we only build Linux images for you. In the next version, we will support Windows and Mac images as well. So our images currently do not run on Mac M1, so we'll be supporting Mac M1 as well, right? So the base image is Ubuntu for currently whatever we ship. And then we have what we do is we take the zip installer, so which is only 146 MB. We unzip that ColdFusion zip installer. We run cf install silently using whatever silent.properties, these installer properties file that we ship. We run that along with using this installer.properties file. We apply whatever latest update is available. So currently we are on update 6. We'll be shipping the latest update 7 today itself. So you'll be seeing ColdFusion 2023 update 7 and 2021 update 14 being released today. So with that, we'll also release a new Docker image as well. So on top of the base ColdFusion, we installed the latest update using, again, we'll install that update silently using, again, a silent properties file. Then we copy few scripts which is required for in all the environment variables that we support along with the Docker image. And then finally define the startup script. So that startup script is responsible for bringing up the ColdFusion services and as well as applying whatever settings you've defined using the environment variables, right? So let's see what all environment variables we support. So we one environment variable is required. So every time you bring up a ColdFusion container, you need to pass this environment variable, accept EULA. apart from that, we support a number of optional environment variables, like serial and previous serial number for activating your ColdFusion server. Password is basically to define the password for your ColdFusion admin. So you could change your ColdFusion admin password using this environment variables. Then enabling or disabling secure profile settings. You can configure an external session storage, which we support as Redis. So if you say true, you have to define your Redis host and port. Then if you've defined configured password for your Redis server, you can define using this external session password. You can also configure external add-ons with your Docker image. So since this Docker image is a zip installer, we do not have add-ons installed with it. So it just has core services. So you can install, you can configure external add-ons with this core image, right? So you can define, if you say true, you can define the host and port for your add-ons container. And then you can define what, if there is a Solar username or password, you can define it using these environment variables, add-on username and password. You could also define the PDF service name. So PDFG service runs with a particular name, so you can define what the service name would be. It can run over SSL. You can define if its SSL is true or false. Then you can also define a setup script of your own. So if you define, you can say that CFM page, which has to be invoked on the startup. So that basically has to be present in the web root. Currently, the web root for your ColdFusion image is /app. So you have to mount that /app directory to your local location file path, and then there you could define your setup script, which would be the first script when the container comes up. And once that runs, you can define whether you want to delete it or not. We support two languages, Japanese and English. So you can define, by default, it's English. Then you can define what all packages you need to install. So using this environment variable, install modules. Then we also have import CF settings. So this basically imports any settings in the ColdFusion server. It's a JSON file. So how you can generate is, you can, on your local setup, you could import all your settings using the CF setup binary. So you run that CF setup script, and then you can export your settings into a JSON file, and that can be imported anywhere so that all your CF servers have the same settings. If you're importing any sensitive settings, you also need a passphrase along with that JSON file. So you can define that passphrase in using this environment variables. And then you can import whatever modules you need to install. That also is a text file. That file has to be present in the /app directory. Right. So these are basically all the environment variables that we support with the Docker image that we ship currently. Now we'll see a few demos of how can we extend these Docker images to build ColdFusion applications. Right. So I see there are a few questions. Right. So currently, lockdown security fixes are not done for the image, but we plan to support it. In the next version of ColdFusion, we'll have a lockdown Docker image as well that will be shipping for you guys. Okay. So right. So we'll see for the first demo. This is my Docker Compose file. So in the Docker Compose, you can see there's only one service defined, which is the ColdFusion service, and the name of the container is my app. So it will bring up a container with the name my app. And how does it build the Docker container? Using this Docker file, which is present inside this /app directory. I'll also show you the Docker file. The name of the image is ColdFusion app. It exposes these ports 8500. So 85 on your image. 8500 ColdFusion will be running on 8500, and the same port will be exposed on your host machine as well. We are mounting this directory, my web root, as /app. So this directory will basically become your the web root for your ColdFusion application server. And then we are defining all our environment variables in this file. I'll also show you this file. And then defining the network where this container would be running, which is basically just a webnet, which with this command, it basically creates a network in your Docker environment, which is with the name webnet, right? So yeah, I'll show you my Docker file, which was inside app. Okay. So in my Docker app, Docker file, I'm just building from whatever we ship. So this is the image that is on Docker Hub. So I'm building from that image, and then I'm copying few files. This is my SQL connector file inside CFusion lib. This is required if you have a MySQL data source. If you want to configure any MySQL data source with ColdFusion, you need this connector file. And then I'm copying my application, which is inside this folder, into this app directory. In my application, I am just uh, basically I've written an probe that basically checks whether the tracker application is up or not. Tracker is basically the bug base which on which you guys can log bugs if you find anything on our server. So I've written a probe which basically just checks if the tracker application is up or not. Right. Along with that, I will see the variables environment variable file. So as I had explained earlier, accept EULA is a mandatory environment variable. So you need to define accept EULA as yes. Then I'm defining the password for my ColdFusion admin as ColdFusion123. And then setup script. So setup script is setup coldfusion.cfm. We'll see this file as well. This file has to be present in your web root. Since the web root is mounted to my web root directory here in this folder itself, so we'll the setup ColdFusion file should be present here. So we'll see what this file is. And then I'm enabling secure profile, and along with that I'm installing few modules. So I need mail scheduler and MySQL module, and then I'm importing few settings as well. So for using this cf setup export JSON file, and for importing the setting I need the passphrase. I'm importing few sensitive data, so this has to be also imported. Okay, so in the JSON file, if you see, it has few datas for mail, related to mail server. So, and I'm also importing a schedule task. So once the Docker container is up, you should see a schedule task and few settings related to mail being there on the CF server. So that is the JSON file. And in the setup ColdFusion CFM, I'm basically just creating a data source. Since since the MySQL connector is already copied, there should be no issues in creating this MySQL data source. Okay, right. Okay, now I've, for interest of time, actually I've already built this using the Docker Compose command. So this was, I just said Docker Compose app -- build, and it built this my app. So if I go to my ColdFusion admin, so I had already exposed the 8500 port. So admin, and then I'm typing ColdFusion123 because that was the password. So I go to server settings, and on under mail, few settings have been configured, like the mail server is my mail server, and username is mail user, and all of that. In the schedule task, there's one schedule task that is already configured, which is a tracker probe task, and it basically checks whether the tracker application is up or not. And then it should have also have created a MySQL data source. So you see there's a MySQL data source also being created, right? So that is a simple application built on top of whatever image that we provide. Let's move on to the next demo. So yeah, so in this demo, let's first take a look at the Docker Compose file. So in the Docker Compose file, here you can see there are three services: ColdFusion, add-ons, and Redis. So add-ons is basically we are configuring external add-ons along with the ColdFusion, and then we are also configuring a session storage, external session storage, which is Redis. So we're defining three containers. The name of the three containers is my app3 CF add-ons and my Redis. Okay, and this is built using a Docker file which is inside the /app directory, and this depends on Redis and add-ons. So basically, if these two are not up, this service will not come up. Then I'm exposing 8500 to this port. Since 8500 is already, I've already binded to the other application, so I'm using 8503. And then I'm also binding, mounting few volumes. So /app is being mounted to my web root, and then I'm also mounting /data to this my test files. Then I have a environment variable file, which is this variables.env. I've defined a health check for whether the add-ons service is up or not. And all of these are part of the same network, which is WebNet. Add-ons is built from whatever we have on Docker Hub for add-ons. We also ship, along with ColdFusion Docker image, we also ship for ColdFusion add-ons. So it's being built from that image. So the add-ons is running on 8995 port. We are exposing that port. This is the environment variable. We'll see this file as well. Redis is being built from whatever is available on Docker Hub for Redis latest. We do not ship this image. We are using the publicly available image for Redis. And then we are exposing this port 6379 on which Redis is running. And then we are mounting whatever Redis data is being created inside /data, that to our local directory Redis_data. Okay, so we'll first see a Docker file for ColdFusion. So it's inside app directory. So you can see it's inside app directory Docker file. So yeah, this is my Docker file. I am just building from it's a very simple Docker file. I'm building from our whatever ColdFusion image that we ship, and I'm copying the same tracker probe application to /app directory. Okay, and then we'll see the environment variables file for ColdFusion service. So again, it says accept EULA as yes, because that's the required one. And then similar for password and then setup script is that CFM file. We'll see this file as well. We're enabling secure profile. And since we'll be using the add-ons and session storage, so we need to install these modules. Search is for Solar. HTML to PDF is for HTML to be generating PDF files from HTML. And then for storing your session storage externally, we support Redis. So this module has to be installed, Redis session storage. And then we say configure add-ons as true. Add-ons host is add-ons because the name of the container in the Docker Compose file, if you see, is add-ons. The service name is add-ons. So we say host as add-ons. And the port is 8995. Similarly, we're configuring the external session storage. The host name is Redis again because the name of the service here is Redis. So Redis, and the port is 6379. Right. We'll see the startup script that I was seeing. So startup script, where is the startup script? We can see from here itself. So startup script should be inside the /app directory, which is being mounted by in this directory, from this directory, my web root. So I'll go to my web root and see the startup file. Yeah, so in my startup file, I'm just creating a collection. If my add-ons gets configured correctly, this collection should be created. Okay, and we'll also run this HTML to PDF to see if the HTML to PDF engine was configured correctly or not. Right. So again, for interest of time, I've already built this. So my app. So my name of the in the Docker Compose file, if you see, the name of the container was my app3. So that's already built. I've built this. All the services are built. So if I go to this admin, again my password was changed. So I'm using ColdFusion 123 as password. And inside server settings, first we'll see whether the external session storage was configured or not. So if I go inside memory variables, you see that the session storage is set to Redis, and we've set it as Redis is the host name and the port is this. If I verify the connection, it says successful. I have not defined any password, so this is empty. So my session is now currently being stored in Redis. Uh, so all of these packages were not installed. Now the next was Solar, right? So for collections, if you see, that collection was created, right? So my Solar server is also configured correctly. So if you see, the host name is add-ons and the port is same, right? Then for PDF service, I have a PDF service as add-ons container, and if I verify this, this says connection status is okay, right? Now if I go and run that HTML to pdf.cfm file, it should basically generate a PDF. Yeah, so it's generating that PDF, so it means that the PDF engine was also configured correctly, right? So let's just see if there's any other questions you guys have. Okay. So startup script should be present inside your slash app directory. So for your ColdFusion Docker image, your web root is the slash app directory. And here in my case, I've mounted the slash app directory to my local directory, which is my web root. I go here, right? So this is my web root. So this becomes basically the web root for your Docker container. If you want to see it, I can also show it to you guys. So I do a Docker PS. I'm not sure of how much of this is visible to you guys, but I can just check that. Okay, so the one where 8503 is exposed, right? So that should be, yeah. So this is my container ColdFusion app 3, right? So now if I go to docker exec -it, I do ColdFusion app 3 /bin/bash. Just take the container ID 368. Okay, so I'm inside that container now. So now if I go to slash app directory and do a ls, you can see that script is inside that slash app directory, and that actually is your web root for your ColdFusion server. So if I go and check the web root here, you can see those files as well. So you see those files are also there. So that is basically your web root for your ColdFusion image, and inside that web root you should define your setup script, which is the CFM page that gets executed once your container is comes up. I hope I am clear. Okay. Containers. So you would have to have another container for your web server, and then you can connect that. So you'll have to move few files here and there, and then you can bring up that. uh, I can have that demo as well. I don't have that, but I can send that across for you guys to have that Docker Compose with both ColdFusion and web server running, and connector being configured between the ColdFusion app server and the web server. Okay. This is all related to that. Okay. Licensing. Okay. So you can license your containers using license key. As of now, we're using one license key. You can activate, I think, 8 containers. I think that's the limit. Uh, but I'm not very sure about it. I can check with the team. Question answer tab. Okay. Fine. Okay. External add-ons is basically the add-on services. So add-on service includes your Solar server and HTML to PDF engine. So for that, we have a separate image that we ship. So just like ColdFusion Docker image, we have a Docker image for your add-ons. With the Docker, CF Docker image limitations. Okay. Uh, Good question. Limitations. Not sure what are the limitations currently. I haven't faced anything, but if you guys are facing something, let me know. Or you could log bugs with the Cold Fusion with us, and then maybe we'll try to fix that. Okay, so let's move on to the last demo that I have. Okay, right. So in the last demo, I'm using the Docker Swarm. So it basically creates multiple replicas. I'm also creating replicas of your services. So if one of the replica goes down, the other takes up. So in this case, you will never have a downtime. So I'm having a similar setup. So I have a Cold Fusion, three services defined, same three services, Cold Fusion, add-ons, and Redis. No complications. It's similar. I'm using for add-ons. I'm again using whatever image that we have. For Redis, I'm using the publicly image that is available. And with Cold Fusion, same. I'm mounting these volumes, and this is the port that I'm exposing. And then this depends on Redis and add-ons, and then I've defined the health check. The only difference from the previous application is for the deployment, I have both as replicated, and then I have defined there are two replicas. So basically, for your Cold Fusion service, there'll be two services, sorry, containers being created for Cold Fusion service, and that is defined by two. And then if one, like if there's one goes down, the other will be taking up your request. So basically no downtime, right? So let's see how we bring this up. So even for this, I've already brought it up. You just have to say Docker Swarm init. So this initializes your Docker Swarm, and to deploy it, you have to just say Docker stack deploy, and then define your YML file, the Docker Compose file, and the name of the services is CF services. So I've already done these two steps. So if I just want to see what all services are defined, I'll have to do a exit from the container. Do a clear. Docker stack. Yes. The name of the service was CF services. So I'll just say CF services. and then you can see for add-ons there's only one replica, since we have not defined how many replicas should be there. And then for cold fusion there are two replicas, one and two, and for redis there's one replica. Now suppose if you want to make any change in your docker compose file, you just have to make that change and do a redeploy. So suppose we've released a new image, right? So now you want to take that new image, so you say ColdFusion latest or ColdFusion, and then you say you want to build from some other image, right? So you can say ColdFusion 2023 colon latest, right? So if you want to build from some other image, you just change the name of the image, and then you do a docker stack redeploy. So it says it's updating the service because it's redeploying it. Now, if, so once it's updating, if I still do docker stack ps, you will see that one of the replica is shutting down because it's getting updated. The other is still up. So there's no downtime basically for your application. The other replica will serve all your requests while it's updating the first replica. So if I again do a stack, it's still shutting it down. It will bring up that image again. So that's the advantage of using the Docker Swarm. Right. So that's all I had from my side. Uh, Basically all the demos. Let me know if you guys have any questions.